Hello and welcome to today's science lesson. So first of all, guys, can we all turn to wave and say a big hello to our friends on camera? Hello. And we'll begin by doing our meditation sequence. So I will sit down, take 2 fingers, find our heart center, left hand on our laps, and close our eyes. When you're ready, guys, you can open your eyes and come back to the room. And next we'll do our stretch sequence. So let's stand up and push in our chairs. And we can begin by stretching up high to the sky. High as we can. And then back down to touch your toes. Now we'll stretch up high one more time. And this time, can we go tippy toe high? And while we're there, let's have a wave side to side. Excellent. And let's go down to touch your toes again. And now we can stand up and have a shake. Arms and legs, shake your legs. Shake your arms. And now we'll do some rotations. So let's go left, right, left, right, left, right, left, right, left, right. Excellent, guys. And now we can do stretches. Let's do 5 to our right. 1, 2, 3, 4, 5. Then we'll do 5 stretches to our left. 1, 2, 3, 4, 5. Excellent, guys. And now we'll take our right hand and find our left foot. Left hand, right foot. Right hand, left foot. Left hand, right foot. Right hand, left foot. Left hand, right foot. And to finish, guys, we will do 5 claps. 1, 2, 3, 4, 5. Excellent. Have a seat. So recently in science class, we've been learning a lot about the different states of matter. We've already learnt about the solids, and in our previous lesson we learnt about liquids. Correct, guys, well done. And liquids is L-Q-U-I-D-S. So remember, if it's not a solid, it might be a liquid. And liquids are things we can touch, but they aren't things we can hold. We will get wet when we touch liquids. And remember, liquids can change shape because when we pour them into different containers, they change to the shape of the container. Now, can liquids change size? Yes, they can, because if the container is a different size, the liquid would also change size. So we know liquids can change shape and can change size. Because remember our practical experiment in the previous lesson, we had a glass, we had a bottle and a cup, and we filled them with water. And each of the different containers, the glass, the cup and the bottle, were a different shape and a different size. And each time the liquid changed shape or size to fit the container. That's what the properties of liquids are. But did the liquid change volume? Remember when we poured it into the bowl and then we poured it back, did the amount of liquid stay the same? Yes, it did. When we poured it from the bowl and then from the bowl back into the container, the liquid stayed the same amount. So what that meant is volume does not change. Volume does not change. We can change it ourselves. We can change the volume by adding more or taking away. But on its own, the volume of liquids does not change. So these are the three properties we found about last time, guys. Change shape, change size, and volume does not change. Not by liquids on its own. Now, who can give me some good examples of liquids that you know? The most obvious one. Coffee, okay. We've got coffee. C-O-F-F-E. Coffee. Water and orange juice. Orange juice. Green tea. Okay, let's have green tea. Now notice at the moment you've mentioned all things that we can drink. How about some liquids that we can't drink? Who can think of anything? Alcohol, yes, certainly. Children cannot drink alcohol. That's a good one. Coffee, we can drink. We can drink. Milk, we can drink. There are other types of liquids. Like who can think, what is it that we put into our cars or our motorbikes to make them go? Remember, oil. Oil is a liquid, but can you drink oil? No, you're not a car. You're not a motorbike. If we drink oil, we'll get very sick. So just to emphasize that there are some types of liquids we cannot drink. Any other ideas, guys? Drink or not drink? We've got coffee, water, milk, oil, orange juice, or any type of fruit juice, apple juice, and green tea. Now notice that all of these words in blue are all liquids, and they will all have the same common properties. Change shape, change size, and does not change volume. When we say does not change volume, what we mean is the volume will not change on its own. If we have a glass of water and we pour half out, then the volume changes, but that's us doing it. The water on its own will not change. And that's what we mean by gases, guys. So very well done. That was very well remembered. And now, in today's lesson, we're going to learn about the third and final type of state of matter. We've learned solids, we've learned liquids, Can anybody remember what we're going to learn about today? Gas. Gases is the final state of matter. And gases is sometimes the hardest state of matter to detect because sometimes we cannot see it. Like in this room now, who can tell me what type of gases we have in this room? And think about when we're breathing. Oxygen and
Carbon dioxide.
yes, so there's at least two types of gases that are all around us now. Can we see them? No. How do we know they're there? By breathing. Everyone just take some deep breaths now. Feel your chest puff up and then puff down. And that's your breath moving in and out. And if you want to do another test to see if gas is here, what I can do is I can simply hold a piece of paper like this and I can blow. Did the paper move?
Yes.
That's because a gas is being blown against it. I'm holding the paper and blowing carbon dioxide. And you can see the force of the carbon dioxide is blowing the paper. So we know gas exists. It's just that not like solids or liquids, we can't see it and we can't touch it. So what we're going to learn about today are some of the different properties of gases and how we can detect that it's really there. So now we've got a PowerPoint presentation for our students to observe, listen to, and also practice speaking about some of the different types of gases and the properties they all display. So let's turn to look at the TV screen, please, guys. So let's take a look at our PowerPoint presentation, States of Matter, Gases. Yes, today we're going to concentrate on gases. Now, first of all, have a look at the picture. What can you see, guys?
Sky.
The sky. And what is the sky? Clouds, yes. Now, what do you think clouds are made of?
Water.
Not really. If it's water, it rains. Clouds are gas. When you see them big white things in the sky, they're not solids. They become liquids, Prel. When we get the rain, that's the gas turning to liquid. But when they're like that, is there any rain in the picture? So our clouds are gases. Gas, matter particles are far apart and not arranged in a fixed pattern. Yes, you can see the three different states of matter here. First of all, we learned about the solid matter particles. Now you can see how they are all tightly packed and close together because solid things are stable. So we can see in the first picture the solid matter particles. And the solid matter particles are all closely packed together and rigid. Because we know solid objects don't move by themselves. We can handle them and pick them up. But then, if we look at the second picture, the liquid matter particles, they're not as close together. They move around slightly because liquids are not as stable as solids. Liquids can move about in a glass or a cup. If we put a solid into a cup, it won't move around by itself. But today, we're looking at gases. And gas matter particles are very far apart and they can go anywhere by themselves. They're free, not stable. Gas can move anywhere, do anything. If gas is in a cup, it can move out of the cup. If gas is in a bottle, it can move out of the bottle. So here you can see the gas matter particles, not fixed and far apart. Gas matter particles can move freely in all directions. Yes, and the best way to demonstrate by ourselves is to use our breath. If we blow in a direction, you can feel it on your hand. Or do it now. You can feel the breath on your hand when you blow. And then If you move your head and your hand into another direction, blow again. And you can feel the gas blowing against your hand. That's the gas matter particles moving any way they want. All gases have no fixed shape, and the size of gases can change also. And you can see here, what can you see in the picture, guys? Steam or smoke. Now this steam and smoke can go anywhere. Usually depends on the wind. Whatever way the wind is blowing is the direction the gas will travel. So it looks as though the wind is blowing this way, because that's the direction of the gas traveling. Now, is the size of the gas all the same? No. We can see here, there's big parts of gas. But here, it gets smaller. And here, smaller again. So the size and the shape of gases can always change. Gases can be invisible, tasteless, and odorless. Okay, now 3 new words there. Invisible. Anybody know what that means? We can't see. Gas is here, but can we see it? No, that means gas is invisible. Can we taste gas? Try to eat the gas. No, gas is tasteless. Even though the gas is in our mouth, when we breathe, we have gas in our mouth, but we can't taste it. It's tasteless. And now, try to smell. Can we smell gas? No. Usually, gas is odorless. So invisible, can't see. Tasteless, can't taste. And odorless, can't smell. They're the properties of gases, mainly. There are some exceptions. Other gases we can see and smell. Now, who knows where this picture is taken from? Stove, excellent prayer. Yes, you see, this is what we call cooking gas. And we light cooking gas on a stove. This is how we cook food. We take the gas, then we use a little spark to create a flame. But if we don't have the flame, if we just let the gas flow, you will be able to smell that gas. And it's dangerous. The shape of a gas depends on the shape of its container. Similar to liquids. Whereas liquids will change shape to a container, so will gases. And a good example, who can see what these are in the picture? Balloons, hot air balloons. So you see here, we have all of these different balloons. Some of them are different shapes. What do you think's inside? Air. And what is air? Gas. Excellent. So you see how the air or the gas will change shape depending on its container. Does anybody know where this is? Chiang Rai. This is Sing Park. Every February in Sing Park, Chiang Rai, we have a balloon festival. And it's very good to go and see all the different types of balloons. A gas can flow freely from one container to another. Yes, remember earlier in the PowerPoint when we seen the gas particles where they can flow and go anywhere by themselves. Here we have gas particles in the top part and they can flow freely and go into the next part. Same with the gases inside of us. We have oxygen and carbon dioxide, but if we blow into a cup or a balloon, the gas will go into the cup or the balloon. So gases can flow freely. Unlike solids, and liquids, a gas has no fixed volume. Okay, so that's the main difference between solids and liquids. With solids and liquids, their volume stays the same. But with a gas, the volume can change by itself. We can compress it to make the gas volume smaller, or we can expand it to make the gas volume bigger. And a good example of how to do it, what can you see in the picture? Balloons, yes. If we blow into the balloon will expand. That's the gas expanding. But then if we don't tie the balloon and we let go, what happens to the balloon? It flies away and the gas gets smaller. The volume decreases. Any questions, guys? That was brilliant. Well done. Welcome back to class. We hope your students enjoyed the PowerPoint presentation to learn more about gases and their various properties. And what we've got now is a few practical experiments for our students to understand more of the behaviour of gases based on their properties. So teachers, what you'll need to prepare prior to the lesson is you will need one inflated balloon, but not inflated totally, because what we're looking to do is squeeze it slightly and demonstrate it can change shape and size. So secure one balloon inside a bowl or tray, and then you will need an amount of bubble liquid that we can use to blow bubbles, and that will demonstrate how gases can move freely by blowing the bubbles. And then the third and final experiment is with another balloon that we will demonstrate can change volume. And the reason for that is because it's not tied yet. I need to blow it up first, and then before I secure, I will let go of the balloon. And we will see how the balloon travels as the gas escapes and the volume changes. So these are the three experiments we will do. And what we'll do now is write on the board the table for the experiments. So first of all, guys, the name of our master today, gases. We're looking at the behaviour of gases. And we've got three different experiments. So the first one we're looking for is, will gas change shape and change size? Okay, so that's experiment number one we're looking at. And then the next one, experiment number two, we're looking to see if gases will move freely, or will they stay in the same place? So we want to know if they'll change shape and change size, and then secondly, will the gas move freely? And the third and final experiment is we want to know is, will gases change volume by themselves? Now remember, solids and liquids will not change volume by themselves. They'll remain the same. But is that also true of gases? So the third experiment, change volume. So altogether, guys, we're looking to see if gases will change shape and change size. Second experiment, we're looking to see if gases move freely. And then the third and final experiment, we want to know if gases will change volume. Okay, so time for practical experiment number one. And what we can use for this is a balloon, and it's already inflated. Now I will demonstrate first that if I apply pressure to the balloon, not too much, my students are very scared, they don't want to bang. But what I want to show is that if we squeeze the balloon, not too hard, does the shape change? Does the shape of the balloon change when I squeeze it? Yes. You can see the balloon will change shape. The balloon will change size. And what I'll do now, I will pass to my students, and one by one, they can all try it out for themselves. So when we're doing the practical experiments, allow your students to demonstrate too. So let go. And if you're too scared to do it, you can just pass on to your friend. Let go to bang pon. You see, bang pon can squeeze it and show how it changes shape. And then pang pon to preu. You see, just squeeze the end slightly, not too hard. Does the balloon change shape? It changes shape, it changes size. That's because the gas inside will move with the shape and the size. Excellent. Now, on to Pat. Pak bone, give it a squeeze. Don't be scared. Give it a squeeze. And net. Okay, excellent. And now back to teacher. And you see, the balloon is still fine. Squeeze it to change the shape and the size. So experiment number 1, guys, what's our result? Change shape? Yes or no? Yes. The gas will change shape. We've seen the balloon change shape. How about the size? If we squeeze it, will it change size? Yes again. Y-E-S. So we know that gases will change shape and that gases will also change size. Now, it's time for experiment number 2. Move freely. What we want to demonstrate is if we can take a gas and blow it, will the gas move whichever way it wants to go? And a good way to demonstrate this is with some liquid bubbles. Because what we can do, we can blow the bubbles and then we can see how the gases or the gas within the bubbles will move wherever they want. So I will go first and then my students can have a go too. Make sure you've got some liquids on your bubble maker and then we can blow like this. Now look at that. Look at the bubbles, look at the gas going wherever they want to go. That's what we mean by moving freely. The gases within the bubbles travels whatever way they wanted to go. And once again, we want our students to demonstrate for themselves. So Lakau, for you. So Lakau will demonstrate the bubbles. There you go. Lakau's got some bubbles blowing freely. And now on to Pangpon. Pangpon, big blow up into the air. Excellent. You see, there's the bubbles, the gases within the bubbles moving freely. They'll go whatever way they want to go. Usually it's based on wind. If the wind is blowing in a direction, they will take the gases. And now Preu's turn. Excellent, very good blow. Look at Preu's bubbles. They're traveling wherever they want to go. Some are going up, some are going down. Now for down. Wow, excellent down. You see? See how they're traveling in different directions? Now for Chew. Big blow, Chew. Very good. Okay. Now what you can notice, because we have an air conditioner in the room, the air conditioner is blowing this way. And that's the direction the bubbles are traveling. Now for Nadia. Very good, Nadia. Okay, look at this one here. And yeah. Now for Pat. Okay, excellent, Pat. There's Pat's bubbles into the air and moving freely. Now for Pak Bung. Very good. Wow, lots of them, and they went down very quickly. But well done, Pak Bung. And now for Net. Okay, look at this one. Net, look at this. You see? One bubble going all the way it went. Excellent, guys. That was a very good demonstration. So now, to answer our question, guys, what's the answer? Did the bubbles, or did the gas within the bubbles move freely? Yes, it did. when we blew the bubbles, did they go whichever way they wanted to go? Did the bubbles move freely, or did they all go in the same direction? Move freely. So we can say yes to moving freely too. And now it's time for our third practical demonstration. And now it's time for our third and final experiment. This time we want to know if gases can change volume. So teachers, for this third and final experiment, you'll need to blow a balloon up, but not tie it at the end. Just secure it with your fingers, because to demonstrate, we're going to let the balloon go and then ask our students to recognize, did the volume change or not? So first of all, guys, look at the first balloon. This one is tied at the end, so the gas is secured. There's no gas escaping from this balloon. There is no change of volume. But who can tell me what will happen if I let go of this balloon? Will the gas stay in the balloon?
No.
Where will it go? Out, exactly. So we should see a change in volume, because what will happen, hopefully to the camera, the balloon will fly around the room and then eventually it will flatten and fall to the ground. So are we ready, guys? 3, 2, 1. There we go. Now, Chew, can you catch it for me? Okay. Thank you very much. Now look at the balloon. The same balloon as a few seconds ago. Is it the same? No. Is the gas still inside?
No.
Now the gas has escaped. So now we can ask ourselves, did the gas change volume? Yes. You see? If we secure the balloon at the end, the gas stays the same. But if not, gas can change volume by itself. And that's why gas is a lot more dangerous than solids and liquids, because it's a very combustible property. So we have now reached the end of our practical experiments. So let's have the answers, guys. Did gases change shape? Yes. Did gases change size? Yes. Did the gases move freely? Yes. And can gases change volume by themselves? Yes. These are the properties that all gases share. Guys, that was excellent. Very well done. And now it's time for our stretch exercise, guys. So let's stand up and push in our chairs. And for this sequence, we will have a game of teacher says. So if teacher says, we can do. If teacher doesn't say, don't do. So, hands on our head. Hands on our hips. Teacher never said. Teacher says, hands in the air. Hands down. Teacher says, hands down. Teacher says, turn around. Teacher says, back the other way. Jogging on a spot. Teacher never said. Teacher says, jogging on the spot. Teacher says, arms in the air. Teacher says, arms side to side. Forwards and backwards. And stop. Teacher says, stop. Teacher says, arms by your sides. Teacher says, into a ball. 5, 4, 3, 2, 1. Teacher says, jump. Okay, and teacher says, please sit down. And now it's time for our worksheet part of the lesson. So teachers, make sure to print enough worksheets for all of the students in your class. And what we want our students to do today is to demonstrate their understanding of gases by looking at each of the pictures, and if they think it's a gas, to write the phrase, this is a gas. But if it's not a gas, we write the phrase, this is not a gas. And what's the first thing we need to do, guys? Write our names on top. So give our students between 10 to 12 minutes for this activity, because it involves some thinking time and then writing too. So let go, this one's for you. You're welcome. Hello, here's yours.
Thank you, teacher.
You're welcome. Down for you.
Thank you, teacher.
You're welcome. Chew for you.
Thank you.
You're welcome. Nadia, here's yours.
Thank you, teacher.
You're welcome. Pat, this one's for you. Okay.
Thank you,
And
teacher.
you're welcome, Pak Bung, and Net for you. So names on top first, guys. And similar to the previous lessons when we looked at solids and liquids, today demonstrate your understanding of gases by writing under the correct pictures, this is a gas. And if you need any help, let me know. If you're not sure, think, is it solid? If it's solid, it's not gas. If it's liquid, it's not gas. But then, if it's not solid or liquid, it must be gas. Gas, excellent, Bang. When you see the steam or the smoke is gas. So what do we think, Net? This is liquid, so not a gas. And what do you think of the fire, guys? Have a look at the picture of the fire. Do you think fire is a gas?
No. Yes.
No?
Yes.
Yes, fire is. Fire is not solid. Fire is not liquid. So that means fire is gas. It is, yes, correct. You can see there, gas. And if you need any help, guys, let me know. Gas, this is. Excellent, guys. Very well done. So it's good to see your understanding of the three different states of matter. Solids, liquids, and today, gases. Not gas, that's liquid. Well done, Bangpon. Remember, everything in the world, everything on our planet, is at least one type of matter. Which one? Not. That's liquid. Think about it. If you touch it and you will get wet, then it's liquid. Perfect. Excellent, Anne. Well done. Great to see your understanding. Okay. So what do we think, Net? Correct. Well done. This is not a gas. Welcome back to class. We hope your students enjoyed the worksheet exercise where they had to look at each of the different pictures and decide which ones are gases and which ones aren't by writing the correct sentence underneath. And that's us done with states of matter now, so we've got a good understanding of solids, liquids and gases. And that's all we've got time for today, so we hope you've enjoyed the lesson and now understand more about gases and their different properties. They change shape, they change size, they move freely, and they can also change volume by themselves. And that's all we've got time for. So we'll see you again soon in the next lesson. So can we turn to wave and say goodbye, guys? Bye-bye. See you again soon.